So some wrap up from the force of gravity versus mass lab. So here's a sample graph. You have force of gravity on the vertical axis, mass on the horizontal axis, and you can see a little table here with the slope and the intercept and whatnot. So if you write the equation for this best fit line, you get the force of gravity equals 9.8 newtons over kilograms times mass plus 0.00148 newtons. And so if you look at this, the intercept here is pretty tiny. Like the force goes up to about 16 to 18 newtons, and we're talking about the intercept being 0.01 newtons. So that's basically zero. So we can treat that as zero, giving us an equation that the force of gravity acting on a mass is equal to the mass in kilograms times 9.8 newtons over kilograms. Now, that number might look familiar to you because that number is the same thing as the acceleration due to gravity, which is 9.8 meters per second squared. And a newton over kilograms is actually the exact same units as meters per second squared because a newton is a kilogram meter per second squared. So this is the same number. And this makes sense because this acceleration due to gravity is a measure of the Earth's gravitational field, how strong the Earth's gravitational field is. And the relationship between force and mass also depends on the strength of Earth's gravitational field. All right, we obviously round that to 10, and this is how we commonly write the equation. The force of gravity equals mass times little g, where little g on Earth we approximate as 10 meters per second squared, or as 10 newtons per kilogram. All right, and that's the gravitational field strength of Earth. It's essentially what little g is measuring. So keep that in mind. The little g applies both in this equation and when we're talking about acceleration due to gravity on Earth. Again, if you go back to what you did in the lab and how you measured it, you can now use this to predict for any mass what the force of gravity will be acting on that mass. So we can test this really quick using our setup from the lab today. We have a mass of 0.505 kilograms. And what I'm going to do is put this mass on the force sensor, and you'll see what the force sensor registers. But before we do that, we can make a prediction of what it should say, because we know the force of gravity equals mass times little g. And if we just put in the value for mass and 10 newtons per kilogram for little g, we obviously should get about 5.05 newtons. So let's test it. All right, we're going to put this on, hang it, and let's see what it comes up with. All right, you can see we have about like 4.97-ish, which is off by a little bit, but not too much. Our predicted was 5.05, so that difference is really tiny overall. It's less than a 5% error.